previously you have learned how to interface with input and output through switches and LED. So for this week, you're going to look at input and output interfacing, but this time we're going to investigate furthermore by looking at 7-segment display. And before we proceed, do you have any questions? Today, internet is not very good. We are having some kind of distraction. So try to be patient. So if you have no question, we will start with our lecture. Week number 4, title 7-segment display. So for this topic, subtopic, you're going to learn some of the basic introduction and operation related to a 7-segment display. And then after that, you will learn how to interface physically 7-segment with a PIC microcontroller. And then the last one, you're going to do programming on how to second type of 7. But 7-segment, or we call it SSD, okay, it's a 7-segment indicator. So it is a form of electronic display, and we use it to display mostly numerical, okay, because the limitation of on the alphabetic side, so we concentrate on the numerical. So there are many type of indicator available. So the 7-segment is one of the alternative that you can use other than complex dot matrix, LCD, and so on. So basically, if you look at the cursor, this is how the 7-segment should behave during operation. So the number here is quite limited. So we can display to any character that the programmer wish to display. So basically, we can find it widely everywhere. Electronic devices, electronic instrument, anything that can be used to display some kind of indicator or numerical. So the 7-segment can be found on these devices. So basically, the 7-segment contain 7, 8, or 9 LED on the chip. So basically pin. Okay, so as you can see from this figure. Okay, so the data pin is around 7 pin, and then the extra one, 8 or 9, would be the DP. We call it DP, or decimal point. So you can see the arrangement. So basically, 7-segment is actually an arrangement of LEDs. Okay, how does this connect? That one we're going to explore later. So basically, contain one single LED, and then the LED is arranged. So looking back individually, this one just for revision. So you can see here, this is an LED. So basically, the most important part that you need to concentrate right now is this one. Sign. The negative side is here, so we call it cathode, and then positive side we call it anode. Okay, so this one you're going to see this type of sign later. Okay, so right now need to be aware of the sign function here, sign location on LED. So basically there are two type of 7-segment you can see here. Okay, so through the diagram shown here, we can see that the difference is quite significant. Okay, so the first one we call it CCD, stand for common cathode display. So basically still 7 segment, but it is how the arrangement of the LEDs. Okay, so for CCD, the cathode connection of the LEDs are joined together to a logic 0 or ground. Okay, like this one. Okay, the common, they connect it together, and this one can be joined together by 0 or ground. Okay, and in order to activate the LED, the 7 segment, logic high or 1 need to be transferred to the input pin. Okay, where is the input pin? This one. This one. So that one is for CCD. CCD, you need to give high or 1 to activate the 7 segment. But for the CAD, common anode display, the common anode display is that the anode would be here. Okay, the positive side. Okay, the anode are joined together to a logic 1. Okay, so this is CAD configuration. So the common here, you can connect this to a logic 1 or to the source. Okay, and in order to activate certain segment or all the segment on the 7 segment, you need to give logic 0 or low, okay, in order to light up certain segment. So for this case, we call it CAD is an active low device. Okay, so for CCD, we call it active high. Why active? So what is active high? Active high, you need to give logic high or 1 in order to activate. Logic for active low, you need to give logic 0 or low in order to activate. So that, okay, the common rule lah. Okay, so this is the arrangement of the two different respective type. We have CCD and then we have CAD. Okay. The difference is how the connection. So you can see for CCD, the cathode connected together, and this one you can connect this to 0 or ground. Okay, so for 0 or logic low, you can connect directly to the microcontroller, and if you want to avoid connecting to microcontroller, you can use just a typical ground. And then for common anode, so you can see the anode part. Okay, the anode part connected together, and then this one can be connected to a logic high 1 or source. And then in order to activate, you need to give logic 0 in order to light up. So you can see here A, B, C, D, E, F, G, and then RDP, and then RDP. So that one we're going to explore later on. So this is how the arrangement of the 7 segment. So basically common anode, and then this one common anode, and then this one common cathode. Okay, so basically this is the important one, because later you will learn A, B, this one G, F, this one A, B, E, D, and then C, and then DP. This one stands for decimal point. So you can see here the arrangement. Okay, the arrangement is similar except for the connection here, active low and the active high. So if you look at carefully from previous diagram, so this is how the arrangement of the LED. Okay, without the masking here, so you can see this one, the arrangement. Okay, so that when when you light up certain segment, it will form to a certain character. So right now this is a common anode. So you can see here. Okay, so in order to light up specific segment, specific part, okay, the pin here, we call it A, B, C, D, E, F, and then F, G, you need to activate, okay, either by logic 0 or by logic 1. That one depends on the configuration of the 7 segment. So looking at this table, this is how you light up. Okay, so like I said previously, okay, this one is the important one, the pin starting from A, B up to G. So total up together. So you can see here, total up only 7 pin. Okay, 7 pin. So total 8 pin when you is include the DP, which is here, the decimal point. So when you total up with this together, so the everything will become 8 pin, which is equivalent to 8 bit. Okay, so without the DP, okay, so this is how you display. This one will represent the character here that you want to show. Okay, so you can see here the animation starting from 6, 7, counting up. And then in order to display logic 0, like this one. Okay, so 6, 7, 8, 9, and then 0. So the part here need to be turned on two configuration. So you can see X here. X is not, don't care. For this case, X will represent either 1 or 0, depending on the configuration, active low or active high. Okay, so if you want to display character 0, so this means that you need to give the pin here starting from A to F, either 1 or 0. And then the G here, either 1 or 0, depend on the configuration. A for CCD, everything here should be 1. And then the last one, the G1 should be 0. Okay. Same goes for the alphabet F. Okay, so you can see here, G, F, and then E, and then A should be turned on, should be activated, should be either logic 1 or logic 0, and then the rest, okay, depend 1 or 0 depending on the configuration. So if you are using TCD, so in order to show character F, G, F, and E need to be high, and then A also need to be high, and then the rest should be 0. So you can see here the arrangement starting from A up to G, which pin should be turned on in order to show the number, the character. So you can see here typical connection. This is 7 segment, and then you can connect directly to microcontroller. However, it is better if you use a resistor, okay, between the 7 segment and also the microcontroller. So the proposed value is around 330 ohm. Okay, so up to, if you including DP, so up to 8 bit. So this means that normally for microcontroller, in order to connect to 7 segment, you need to have a free 8 pin or 8 bit of port. Okay, so for this lecture, you're going to look at multiple exercise. So the theory will be less. So we are looking at example number 1. Write a program and create a circuit to count up decimal starting from 0 up to 9 using 7 segment. Okay, so the CCD, common cathode. And then the delay between 0 to 1, 1 to 2, and so on must be around 1 second. So this is the circuit, the simulation circuit that you need to build. You need to build. So you can see here the simulation here. Okay, only for this software. Okay, only for this simulation software. The oscillator circuit is not required. Okay, but in actual, if you are answering any question, whether from test or whether OBE final, when the question asks you to build design a circuit, clear the reset circuit, and then the oscillator circuit, and then the supply circuit. Okay, but for the purpose of simulation, the two item we can ignore. So you can see here the simulation. Okay, we run the simulation, and then this is switch 1, switch 2. Okay, press. Okay, so this one will come out. So you can see the arrangement, the bit arrangement from port D, okay, start to shift. Okay, according to the number shown here. Okay, 9, 7, 6, 5, 4, 3, 2, 1, and then so on. So that one, for example, example 3. So we're going to look at another example lah. But before that, there are some question. There are some question that is shown here. So based from previous example lah. Okay. The previous example only focus on the connection between a microcontroller connected to a single 7 segment only. Okay. So what happen if we want to add more than one? Let's say for example we start slow. We start by using another 7 segment. So the current total is 2. We want to use 2 7 segment. So how do we connect? How do we connect between these? Connect the data pin A, B, C. You can see here the answer is not possible. Okay. However, it is also possible, but the step would be complex. Okay. And beyond the scope of this lecture. So right now we just concentrate on on another alternative. We can connect 2 7 segment, and then this 7 segment, the data pin A, B, C, D, E, F, G, for both 7 segment, we can connect to a single port. Okay, let's say 7 segment 1 connect to port the data pin connect to port D, and then the second one also connect to port D. So this means that these 2 7 segment, they are sharing the same data pin coming from port D. Okay, so like this. Okay, like the example. They are sharing the same data pin. Apa dia pula? Still lah. Lost
Pin lost.
Ni. Okay, so I continue Continue again this one sorry today our internet situation in Unimed very okay, so everyone can see okay, so you are presenting. Okay. So you are presenting, so we continue Sadly, we continue. Okay, so I try to repeat the question. Okay, so the question is that what happens if we want to add 2 7 segment? Okay, and then the 2 7 segment, can we connect the data pin A, B, C, D, E, F, G for the first one, and then the second one A, B, C, D, F, G. We can connect to different port. Let's say the first one you connect to port D, and then the second one you connect to port C, port B, or port A. Okay, depend. Okay, so can you do that? So right now the answer shown here is you cannot achieve that. Okay, so the best option, you can refer to this figure. Okay, you can refer to this figure. Let's say, so right now you are seeing up to 3 7 segment. But right now, here simultaneously, okay, not individually, as shown by this animation. We want to view it simultaneously. Okay, right now the value is 1 1. We don't want to see 1 and then turn off. We don't want to see 2, turn off, and then we don't want to see 3 and then turn off. We don't want that. We want the display to show 123. Okay, So that is the question trying to achieve. And then the answer to that is we are employing this method, POV. We call it persistent of vision. Okay. So basically the solution is similar like this one. Okay. So but you can see the delay from here to here is quite longer. So by using POV, we try to make the delay faster. Okay. So when the delay becomes faster, the frequency rate beyond what our eyes can see. So after that, the eyes will be tricked into thinking that it is blinking simultaneously. Why? Because the refresh rate from here to here to here is very fast. So that is what the method of POV trying to achieve. Okay, still the same method, but the frequency, the changing from here to here, the frequency of change is faster or larger. Okay, so when the blinking here become too fast, our eyes will be in illusion, thinking that we are seeing one number. So this is what the example one trying to achieve. So you can see here, we have two 7 segments. Okay, so right now we refer to the question first. Write a program. Okay, this one only require for us to write a program only, and then no need to build any circuit related to the microcontroller. So we just build we just write the program. Okay, so this time we are having two 7 segments. So right now write a program to count up decimal from 00 to 99 using 7 segment. Two 7 segment. The configuration is common cathode. And then when the microcontroller is on, the 7 segment will count up the decimal from 00 to 99. And then when you turn off the whole system, the counting, the 7 segment also will be turned off. So you can see here, okay. And addition to the circuit, we have an NPN. Either one or both. Okay. So we are controlling the Aduh. Okay, can see ya. I don't know what to do ah. Okay, still being recorded ah. Okay. So we continue ah. Sadly to say we continue. I don't know whether you what section ah. I don't know where is the progress ah. What you have been missing ah. Okay, so we are doing right now. We are doing example number 2 ah. Okay, we are doing example number 1. Sorry. But this time we are using 2 7 segment. So you can see here ah. So you can see here. Okay, so this is the pin, the control pin connected to RC3, RC4, connected to RC3, RC4, and then this control pin will enable which segment that we want to turn on, whether we want to turn on either one or both, or turn off either one or both. Okay, depend on the program because right now we want to count up from 00 to 99. So this one will be acting as control pin to activate either this one or this side. So we look at the solution first. This one, like the previous solution, we are using array up to 10 individual element array. And then this array is variable type char. So char is the range for char is from 0 to 255. Why 0 to 255? Because unsigned. Okay, because unsigned. So when unsigned, the value is 0 to 255. If you are using sign, so this means that half of this 255. So the range would be, the new range would be minus 127 up to plus 128. So you need to use other type declaration if you are using sign. However, the current format is unsigned. So sufficient if you are using char only. So after the main subroutine, you introduce an integer variable unsigned positive value with initial value of 0. And then other variable also included here, high and low. You represent it as integer and the value is positive because of unsigned. Integer value is very much higher than the char, this one, okay, char. Because this one, the range is from 0 up to 65,000, more than 65,000, 16 bit. This one only 8 bit. Okay, so this means that the variable here and here and here can receive very large of data, okay, not more than 65,000. Okay, so if we refer to this one going to be output, this one also going to be output because this one need to control these 2 7 segment, this one need to light up certain segment, okay, of this part of the device. So everything must be configured as output, starting from 3D output, and then the 3C also need to be set as output. And then initial value CTR also 0. Okay, so you can see you can also repeat the value. And then high 7 and then low 7 also the initial value must be 0 also. And then you go for continuous looping. Okay, so continuous looping high, the variable high will store value coming from CTR divided by 10. Okay, so right now the current value of CTR is 0. So 0 divided by 10. Okay, you store it inside high. And then low only restore the modulus value of CTR percentage 10 or CTR divided by division. Any remainder it will store in low. And then after that sec 7 bracket square bracket high. So this means that high here, okay, value of high. If the value is 1, so this means that 0, 1, it will display the number 1. It depend on the process here. And then after that, this one, high 7 and low 7. We know that high 7 and low 7. We know that high 7 and low 7 come from we know that high 7 and low 7, this one, these two come from RC3 and also RC4. Okay, so it is an output. So right now we want to enable first high 7, high 7 RC3, okay, RC3. So we want to on only the first segment here, okay, RC3, this one RC3. Okay, C3, and then after that, this one turn off 0, okay, turn off 0, and then this one will be disabled. So, and then after that, when you completed this process, you wait for you wait for 5 milliseconds. Wait for 5 milliseconds, and then after that, okay, you disable. We disable both RC3 and RC4. Okay, so these two 7 segments will be turned off. And then we repeat the process for the low side of the 7 segment, okay, which is here, okay, coming from this process. And then we disable here, this one, the first one, turn off, this one turn on. And then after that, we include any value from this calculation to port D. Okay, and then okay, sorry again. Okay, so you are still being patient. So we try to observe. We try to observe solution simulation for 1C. Simulation for example 1. Okay, this is the two circuit. Okay, so you can see here there are no transistor, So this means that it is still behaving like a selector switch. Okay, but I'm not including the transistor. Okay, so this is what happens when we run the program. So you can see here the blinking rate. Okay, starting from 0 and then we stay here. But the objective is not achieved. Right now the objective you can see is not achieved. This is not what we want. We want between these two digits they are simultaneously display. Okay, we want to do that, to achieve that. Okay, however, so you can see very difficult. Okay, because of the switching between RC3 and RC4. So you can see here. So okay, this is for port C. Okay, the switching. Okay, the switching part. Okay, RC3, RC4, RC3, RC4. So why this one 1? Okay, that one we will try to investigate later. Okay, this is it is showing the output, but the objective is not what we want. Okay, so we go back to the programming side. Okay, this one example. Okay, so right now, so you can see, the problem is that when we debug, we are seeing that other bit also being shown to the being present to the port, even though it is not programmed. Okay, I repeat again. So you can see here. Okay, this is not what we program. We only configure these 2 bit. Okay, why does this bit exist here? So we go back to the program. So we try to propose a solution. So you can see here. Okay, trace C, trace D. Okay, so right now trace C is showing additional bit. So okay, let us see whether the solution can be achieved or not. So we try to declare port C. Okay, port C or port clear all the port from port C. So then we observe whether this is achieved or not. Okay, build success, and then you go back. You go back to solving the problem. Okay, still the same. Okay, still the same. Okay, this, so for this example, so you can see. Okay, so maybe we can explore other example here, other solution. Okay, so right now this part also, the solution for this part also not as what we expected. So you can see the explanation shown here. The program before this can display both of 7 segment. It is displaying 2 value from these 2 7 segment, but we cannot view as a single number. Okay, even though 2 digit, we cannot view as single number, as a solid number, because the number is changing too fast. Okay, so we need to add some delay. Okay, this one would be better option if you are using hardware. Okay, so you can see fully, but for simulation, the output might be vary according to the speed of the computer. Okay, but what happen is that the first thing is that the switching frequency is too fast. Okay, the delay or refresh rate some or period to keep long enough for us to see the changing value. So you can see based from previous simulation, we can see that certain part is not blinking. The certain part is not blinking. Why? Because of the higher refresh rate or higher frequency. So the next program we're going to introduce, we're going to make the program delay. We're going to stall the program, try to introduce certain delay, value of delay around 100 times before we continue with the counting process. Okay, so the number here is not very subjective. So we try to achieve through try and error. Okay. So and then the last one is an alternative method. So this one we're going to explore later on. But right now we look at another solution. Produce a counter. This is a counter using a for loop. Okay, the counter will count up to 100 and then to delay the refresh rate. And then the rest will still be the same. Okay, the rest will still be the same. Okay, so this one we'll try to solve. We try to solve the higher frequency of refresh rate. So we try to simulate and try to observe what is happening. So you can see a little bit slower. So you can see 2, 3. Okay, still the same. Okay, so you can see here. Okay, still the same. Okay, but this time the rate is much more slower. Okay, what we want to we want to achieve is that this one should be 1, 1 to 0, 1 to 3, and then 9, and then 1, 0, 10, 11, 12, 13, and so on. Okay, so you can see still not as expected. So how do we solve this? So therefore we can observe the last method, okay, by introducing a decoder. So this decoder, what does this decoder do is that it will receive BCD signal, and then it will transform this BCD signal to a 7 segment. Okay, so we know that BCD only 4 bit. Okay, 1, 2, 3, 4, okay, or 0, 1, 2, 3, only 4 bit. Okay, it only receive 4 bit of value from the microcontroller, and then it will convert these 2 bit into 7 segment from A, B to C, and then up to G. Okay, so by using a decoder, okay, we shown here decoder. So this one a binary decoder. So what is binary decoder? So shown here, explained here. Digital conventional logic. So it is just like a converter whereby it receives one form of digital signal and then convert to another form of digital signal. Okay, just like a transducer, except that the scope, the input and output signal must be digital or binary. Okay, so the input must be in term of BCD, binary coded decimal, 4 bit. And then when this 4 bit going into the decoder here, it will be converted to 7 segment display decoder. Okay, so and then the 7 segment you need to connect to the proper pin starting from A, B, C, D up to G. And then after that it will display this type of character, certain character. So the most common one would be what you can see from the market, CD4511 or LS7447. Okay, these two type. Okay, so we are referring right now for the CD4511. So this is the pin up. Okay, the pin configuration, pin assignment for this IC. So on the right side, after the VCC is output. Okay, so this is where you connect to the 7 segment. Okay, but before you connect, you need to put resistor first. Okay, this one go to the 7 segment up to 7 bit. Starting from A, B, C, D, E, F, and then the last one G. Okay, so you can see not in order. So therefore you need to be aware. Okay, so which is A, and then this A need to be connected to pin A of 7 segment. So this one not in order. And then you go to the left side, D1, D2, D3, D4 is the input. Okay, input coming from the microcontroller. The value must be in 4 bit. Okay, 1, 2, 3, 4. We are only receive the BCD, the decoder only receive 4 bit from the microcontroller. So point you need to use the whole 8 bit. Okay, the whole 8 bit. So by using this decoder, the microcontroller only need to allocate up to 4 bit of the signal, digital signal. digital code, and then that code, that pin need to be connected to the decoder, and then after that the decoder will transform that 4-bit into 7-bit. So this is the pin arrangement, pin assignment. So this one, just go to the 7 segment. These two pair, D1, D2, D3, and D4 will receive input coming from microcontroller. Must be 4-bit. A, B, C, and D are the binary input. Mana? Okay, no problem. Okay, so no problem. Okay, and then A, B, C, D. A, B, C, D would be here. D1, D2, D3, and D4. And then A, B, this one capital, uppercase, uppercase. A, B, C, D, this one, binary input, and then the lowercase A, B, C, D, E, F, and then G, this one, the driver signal to the display element. So this one need to be connected to the 7 segment. And then LT, the light test control, you need to give 0 in order to active. In order to make it active, you need to give 0. Okay, so what does this LT do is that it turn on, the all on of all the segment from the 7 segment. So this means that if you refer to this one, all here, 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 and then here, here, here. Okay, this one, if you are not connecting, so this one will not show. And then BL, upper line, blank. Okay, the LT turn on, BL turn off, blank when activated, also active low. So you need to give 0 to turn on, okay, for LT and also BL. And then LE is the latch enable. So latch enable is just like a switch. Okay, whenever you want to use it, you turn on. If you don't want to use it, you turn off. Okay, so this one is the latch enable. It will enable the latch inside this IC. So we refer to this figure. Okay, we refer to this figure. This one, we try to explain what is the purpose of the LE. Okay, so the IC, CD4511 incorporate an input latch, okay, which is here, okay, so that it can hold and display a steady digit as a part of multi-digit count. If you want, let's say, if you want to count from 0 to 100 to 1000 and so on. Okay, so this latch will hold that particular value, okay, without blinking like the previous one. So it will hold a steady value while the other new count is being accumulated. It's being count, either count up or count down. Okay, it will not show. Okay, it will just hold to the steady the be updated. Okay, if new number available and then LE is 0, okay, so that particular number will be shown or updated. Okay, so and then what happened when LE becomes 1? After that, after the updating process, you go back to giving LE 1 so that it can hold the logic, it can hold the value. Okay, so if the new value is 2, you turn on by giving 0, then the latch will hold that number 2 and will update to number 2, and then to hold that value, you turn off again by giving 1. So that is the working process, working flow of the LE. And then looking at this function table, so this time x is don't care. Okay, it can be either 1 or it can be either 0. So you can see here we have up to 3. 3 column, and then the last one 4. 4 column. And then this one will be connected, will be shown, will be display value from the 7 segment. Okay. Starting by 0, 0, 1, 2, and so on. Okay. So we are only interested on this region only, okay, between 0 and also 1. Okay. Why do we interest in this region? So you need to refer to this one. Okay. LT, BL, and LT, LE, BL, and LT remain the same. Okay. Starting from 0 to 9. Okay. They're all the same. Okay. Other than that, so you can see the movement, the status of LE, BL, and LT start to change. Okay. So we are only interested on this region only. Okay. 0 and 9. So basically, so you can see L, E, BL, and LT, the status remain unchanged. Okay. And then the input X is don't care. Okay, but since we are concentrating starting from 0, so you can see okay, the input must be low in order to display 0. Okay, this is output, this is input. Okay, when we only have when the input, the single input only high, the first bit becomes high, so this means that number 1 will be shown. Then two input, the 0 and the 1 becomes high, number 2 will be shown. Okay, so the arrangement will increase according to the number. So okay, so what is the significance of the value of LE, BL, and LT remain the same? Because we can directly connected LT and BI to source and LE to ground. So we don't have to change it, and then we need to, if we want to change it many times, we need to connect to a microcontroller. But if the value remain the same, so would be enough, would be sufficient if we could just connect to the VDD, to the supply logic value, okay, 5 volt, and then this one must be 0. Okay, so this one would be sufficient. Why? Because the value of LE, BL, and LT is not changing. Okay, not change. And then after that, this is how you connect. Okay. Make sure to have a resistor between 7 segment and also the output. And then the arrangement, A must always go to A, B must go to B, and so on. Okay, so similar like previous one, but this is the value that we just interest. Okay, starting from 0 to 9, and then the value. Okay, so we are considering only the input. Why? Because okay, if the value of LT, BI, and LE remain unchanged, we just follow this type of configuration, and then we don't have to bother about changing that value. So the only value that need to be changed is the BCD input data 4 bit, okay, which is SW3 to SW0, here to here. Okay, so you need to change here, okay, in order to light up specific segment. So after the semester break, okay, when you going to do hardware, so this one we are referring to the kit, the IC kit PTK40A. So this is the schematic. So the kit also contain a 7 segment, okay, complete, coming together with its own decoder, okay, with its own decoder. So if you want to connect, you need to be aware of the pin connection. Okay, pin connection. Okay, this one already connected. Okay, this one no need to worry except for this one, because you need to write program according to the connection here. Okay, so for this example, write a program to count up decimal from 00 to 99 using 7 segments. So we need to use 2 7 segments to display 2 digits. Okay, the configuration is common cathode. Okay, common cathode. So this means that 85 So you need to give 1 in order to turn on the 7 segment. When the microcontroller turn on, the 7 segment will count up from decimal 00 to 99, and then only turn off if the microcontroller is turned off. Okay, so this is the program. Okay, we are repeating the previous code. Okay, high 7, but this time high 7 go to RE0, low 7 go to RE1. Why? Because you need to refer to schematic. So you can see here. Okay, the LE. So this time LE is not connected directly to ground because we want to enable we want to enable certain part. So therefore we connect LE to RE0 and also RE1. Okay, this one LE connected to RE0, LE connected to RE0, and then the second one also connected to RE1. So we are using only 2 bits from RE0. And then after that, remain the same, but need to declare first, since both port need to be used as output, so data direction register must be declared as output. We are using only 2 port, port C, port E and port D, so trace D and trace E must be set as output. Okay, since we are using trace E, okay, so previous lecture indicate that trace E port, they share the same function, which is as analog input. So we need to disable first the analog input so that we can enable the digital I/O for port E. So you need to disable first. So you need to put this code whenever you use port E and also port A. And then after that, we declare the value of high 7 as 1, low 7 as 1, and then after that, this one we define. Okay, we define high 7 as RE0 as high 7, RE1 as low 7, and then we put 1 into high 7 and also 1 into low 7, and then we do the same thing. Okay, we divide by 10 and then we take the remainder through this modulus. And then port D. So the process, the output from these two calculation, we're going to display in port D. Okay, this one bitwise operation. We're going to n between high and also this binary value, and then after that we enable higher display, and this time we turn off. Okay, only turn the high side only. Okay, after that we do the bitwise operation. Okay, but this time we turn on the other one. Okay, turn on the other 7 segment, and then wait for 1 second. Okay, so this one 1 milli, this one 1000. Okay, we can observe that later on. And then increment counter of CTR, and then if the value is higher than 99, reset it back to 0. Okay, so we look at example first, okay, before we stop our class. Okay, so right now you can see we add new component has been added to the skirt. Okay, output here RE0 and RE1 will be connected to LE. LE, and then this one also LE. So we proceed to running the program. Okay, 1, 2. Okay, very slow because 1 millisecond. This one 6 and then 7, 8, 9, 10, 11, 12. Okay, just count up. No input. Okay, 20. And then up to 99. After 99, it will turn back again to 0. Okay, So do you have any question before we stop our class?